Hello everybody, welcome back to MrMiers Math Channel. Today is an extra lesson in which I'm just going to go over review problems from everything that we've done in Chapter 9. So let's get started. On the first one, we're graphing the rational function, so we got to list the vertical asymptote and the horizontal asymptote. So the vertical asymptote, if you remember correctly, we set the denominator equal to 0 and we solve, and when we solve that, we get x equals -1. So that vertical asymptote is at x equals -1. You can just draw that with a dotted line. And then the horizontal asymptote is whatever we're adding or subtracting to the overall function. So that's a -2. So that means the horizontal asymptote is y equals -2. All right, and then after that, we're going to form our table. And at the middle of the table, we're going to put that vertical asymptote value of -1. All right, that tells us the point at which our function is undefined. So now we're going to pick values on both sides. So some values that we could choose, and I'm just throwing in my example of values that we could choose because obviously what you pick might be something different. I'm going to choose -5, -3, and -2 on the left side, and then 0, 1, and 3 on the right side. And that gives us some reasonably good output values. So I'm just going to plug in -5, and then I'm going to write down the other output values. So to get the output value for -5, we just put -5 in the function where we see x, and that would give us -2, and -5 plus 1 is -4. So -2 on -4 minus 2, which is just 1/2 minus 2, which would be -1.5. And if we do the same thing for the rest of the values, we'd get -3, -1, -2, 0, -0, -4, 1, -3, 3, -2.5. All right, so now I'm going to plot those points. So we have -5, -1.5. Oh, that's why, because I got there we go. Here we go. That's a little bit darker. -3, -1, -2, 0. And then for the branch on the right side, we have 0, -4, 1, -3, and then 3, -2.5. All right, so our function will look something like this, where we have the left branch and the right branch. And key things here is when we're doing this in preparation for a test, we know where the vertical asymptotes are, and we know that our graph can't cross those vertical and horizontal asymptotes. Okay, all right, that's it for the graphing part. Now everything else is basically going to be simplifying. So let's go on to the next example. In this one, we're finding the domain of the function. So to do that, that's just like finding the vertical asymptote. We set the denominator equal to 0, and in this case, we get x equals 5, but that is the value by which this function is undefined. So that means our domain is all values but 5. So I'm just going to write a little cross through that equal sign, so x cannot equal 5. All right, everything but 5. All right, then going down to 3, where we're simplifying. Remember, we want to look for places to factor. Okay, take out those common factors. All right, notice we have an a in common, a b in common, and then 6 and 24 have 6 in common. So we could just write this as 6ab. We're going to take out another 6ab in the denominator here. And to get 6ab, that would just be 6ab times 1. To get 24ab squared, that would be 6ab times 4b. All right, the 6ab cancels out, so we just have 1 over 4b. All right, now moving on to the next one. Now, once again, we want to look for places to factor, so we got two things that are factorable right here. All right, so we want to factor those first. So we're going to factor an 8 out of the denominator in the left fraction, and that's going to give us 8 times the quantity r minus 9. And then we want to factor out, we want to factor the numerator of the second fraction. Okay, that is r minus 9 times r plus 1. Now cancel out all the common factors that we see. Okay, so we have an r minus 9 here, and r minus 9 there, r minus 9, r minus 9. So that just leaves us with r plus 1 on 8. Now in 5, we're dividing the rational expressions. So no longer multiplying like in example 4, we are dividing. So the first thing that we're going to do is rewrite, but as we rewrite, we can also simplify at the same time. Okay, so I'm going to simplify this. I'm going to factor this, and that's going to give us v minus 10 times v minus 7. In the right fraction, remember we're going to flip it, because instead of dividing by a fraction, we want to multiply by the reciprocal. And we're going to factor at the same time. So when we factor this, that's going to end up in the numerator in this second fraction here. All right, this factors to be v minus 10 times v plus 7. Now let's look for those common factors that we can cancel out. All right, so v minus 10 will cancel out. The v minus 7s will cancel out. So what we get left over is just v plus 7 on v minus 2. Awesome sauce, and we're already just about halfway there. Okay, if we see the division like 6, don't let that confuse us. All right, once again, we just want to rewrite. Okay, so we're going to rewrite this. I'm going to rewrite the first fraction, which is the fraction on top first. That's not the one we flip. And at the same time, I'm going to factor this. So if we factor the 5x squared out, we'd have 5x squared times x plus 4. And now we're going to rewrite the second fraction by writing it as multiplication by the reciprocal. And we can cancel out common factors. So in this case, common factor of 5x squared would cancel out, and we would have 5 on x plus 4. If we take a look at 7, for these, we need to get the same denominator. All right, if they don't have like denominators or common denominators, we need to make them have common denominators. All right, so notice 2 is in that 2m cubed. So for that left fraction, all we need is an additional m cubed. So we're going to multiply by m cubed over m cubed. And then we'll have 3m to the 4th on 2m cubed minus 4 on 2m cubed. And now we can combine this. So we would have 3m to the 4th minus 4 on 2m cubed. And of course, the last thing that we should always do is double check and make sure this is simplified. Make sure that there's no common factors amongst the numerator and denominator that we can get rid of. All right, moving on. In example 8 here, notice that there's no common factors between these two denominators. So to get that LCD, what we're going to do is just multiply by that other denominator. So we're going to multiply by x minus 1 over x minus 1 here, and 3x minus 2 over 3x minus 2 in the second fraction. All right, and as we multiply, I'm going to distribute, so 3x minus 3 on the quantity x minus 1 times the quantity 3x minus 2. And then in the second fraction, we'd have 6x minus 4 on, once again, the same denominator because we already got like denominators now. Now we're going to simplify, and remember this subtraction is subtracting that whole quantity, that whole numerator there. All right, so we got to distribute that negative. Okay, so we can rewrite the numerator as 3x minus 3 minus 6x plus 4. You don't really have to write the denominator again because we still need to simplify that numerator even further. We would have negative 3x plus 1 all on the quantity x minus 1 times the quantity 3x minus 2. Awesome sauce. And now I'm moving up to the last bit, which is solving. Remember, if it's just a simple rational expression on each side, we can cross multiply and then solve from there. So if we cross multiply here, we get 5x equals 4x plus 4. Don't forget to distribute, and then solve by whatever means we can. So subtract 4x, we get x equals 4. Awesome. On this one, if we plug 4 back in, we'd get 4/5 on the right side too, so that would be a solution. Now, of course, in more complicated examples, we got to find that LCD first, and then we got to multiply each term by that LCD. So in 10, we have 2a squared as the LCD, so we're going to multiply each one of these by 2a squared. All right, so on the leftmost fraction here, the a squared is going to cancel out. We're just going to have 2 times 1 left. In the middle fraction here, an a is going to cancel out, which just leaves 2a. And then on the rightmost fraction here, the 2a squared cancels out, so we just have minus 1. Okay, and then we're solving, so add 1, divide by 2, and we get a is 3/2 or 1.5. Okay, if we plug that back in this example, it works. You can check it for yourself. All right, for 11, the LCD is already in the problem. It's just n times n plus 2. So now we're going to multiply each one of these by n plus 2. And I'm going to erase this little bit so it doesn't get in the way. I'll just rewrite it here, just in case you didn't have it down. So n times n plus 2 for each one of these rationals. But in the first rational, that just cancels out the complete denominator, and we get 1. And n cancels out in the second rational, so we're left with n plus 2. And then in the rightmost rational here, we just have 2. All right, so that's n plus 3 equals 2, which would give us -1 in this case. All right, and once again, I believe that works as well. All right, moving on to the last one. Which apparently I don't have written down here, so I'm going to write it down. I don't know where it went, but it's supposed to be here. So we have 1 over a minus 6 minus 5 on a squared minus 2a minus 24 equals 1 on a squared minus 2a minus 24. Whew. And you can probably see why I wanted to do this one. It's not as hard as it looks. If we factor a squared minus 2a minus 24, we would get a minus 6 times a plus 4. And that would be our LCD. Sorry, my board's a little off here. So since that's our LCD, we can multiply each one of these by that LCD, which is just a squared minus 2a minus 24. I just like to write it in factored form. Because then it usually helps us on some of these rationals. All right, and now we're going to cancel out what we can. So in these two, the whole thing cancels out there. And then in this one, we are left with an a plus 4. So that's a plus 4 minus 5 equals 1. Simple enough. All right, so that's just a minus 1 equals 1. And we get a equals 2. And that's it, folks. Nice, short, and sweet. If you liked that or enjoyed it or found it helpful, please like, subscribe, and share. Thank you, and have a good day.